Good morning, everyone. Welcome. Start off with, I realize you didn't have any assignment, but hopefully you had a great weekend. And I wanted to see if anybody had a question you wanted to ask. Morning, Rachel. Did anybody have any questions?
What's your favorite part of calculus?
What's my favorite part of calculus? Wow. My favorite part, I guess, is what's coming in the next couple days, where I show you the foundation of calculus. But it's just, I guess it's incredible power. It does, calculus does some things that are, they seem miraculous. And I don't know, that would be it. All right, well, then we'll get started. Today, today's lesson is 1.5. It's inverse functions. And let's dig in. So this is actually from the website. And it shows you how do you find an inverse. And if you look in the box, it pretty much, the introduction at the top says, hey, the inverse of a function undoes the action of the function. If f of 2 equals 3, then f inverse of 3 equals 2. So here's what you do. You've got a given function right here, f of x. Get our pen going here. F of x equals 2x plus 4. So first, change the f of x to a y, and then literally interchange the x and the y, swap them. So right here, we've got the same equation with the x and y reversed. X equals 2y plus 4. And then solve for the new y, which I did down in here. I first subtracted 4 from both sides, and then I divided both sides by 2, and we've got it. Y equals 1/2 x minus 2. So in other words, the inverse of the function 2x plus 4 is the function 1/2 x minus 2. So step 1, interchange the x and the y, and then solve for the new y. Now, the book makes a big deal out of this. And that is when your inverse is itself a function, then they're happy. Like here, this turns out to be a function on its own, 1/2 x minus 2. But sometimes when you find an inverse, the inverse is itself, even though the original was a function, the new inverse is not, and they get all upset. I don't get as upset. I just realize, okay, that's cool, and you're right. So we'll see as we go along here. So here's the one we just did. F of x equals 2x plus 4. Interchange the x, write it as a y, interchange the x and the y, solve for y. Okay. Now, to prove that you really got an inverse, what you need to do is compose the function with its inverse. So here we have the original function, 2x plus 4. Here's the inverse, 1/2 x minus 2. If it's really an inverse, then f of f inverse should turn out to be x, and it does. So you function So we got to, in this case, we have to plug the 1/2 x minus 2 in for the x of the function. So 2 times the quantity 1/2 x minus 2 plus 4. And you can see that when you simplify it, you really do get x. And it should work when you do the opposite, and that is compose the inverse of the original function. So now you have to plug 2x plus 4 in for the x in this function, and you can see it works in both cases. So remember, when you compose a function and then you compose it in the opposite order, normally that will not give you the same result. The only time it works is when you have inverses, and you can see it here. In either direction, it will come out to x. So here we have another example. Find the inverse of the function x squared minus 3x plus 9/4. All right, so we've got our function. We set y in place of g of x, and then we literally swap the two. Well, I guess before we swap, all right, let me, yeah, this turns out to be a perfect square trinomial. That is, if you multiply x minus 3/2 times x minus 3/2, you get x squared minus 3x plus 9/4. So it is x minus 3/2 squared. Now swap the x and the y, and now solve for the new y. So down here, we have, we would first take the square roots of both sides. Notice that's a plus minus. So here, right away, the book goes, whoa, plus or minus, that's not a function anymore. And they're right, but that's okay. You can still find the inverse. Just keep going. Plus or minus x equals y minus 3/2. Add 3/2, and we get this thing down here. Now, the book says that's not a function anymore because of that you've got some above and some below, plus or minus. So you're right, that's an inverse. It just doesn't happen to be a function. And okay, so something really cool about inverses. Here's those same two we did in the beginning. Y equal, the original function was 2x plus 4. Its inverse, as we showed twice already, is 1/2 x minus 2. And when you plot the two, this original one, this one here, 2x plus 4, is this top one, y-intercept of 4. And then the bottom one is this yellow. Hopefully you can see the yellow line on the bottom. And I put the identity function in green, y equals x, and do you notice how the yellow line is the mirror image of the red, the black line, with respect to the identity function. So if you tip your head sideways, you can see we have a perfect mirror image there, and that will always be the case when you plot an inverse on the same axis. Here you can see that true here too. This is the other one we did, the one just a few minutes ago. So we got the function x squared minus 3x plus 9/4 is in red. We found two answers, plus and minus square root of x. I've got the top answer in yellow and the bottom part in, I don't know, I think that's a blue. And you see how this, if you take these two together, that clearly is not a function. It fails the vertical line test, but still, it's an inverse. And if you tip this, tip your head here, you can see the red and the yellow blue are mirror images of each other with respect to the green identity line. That's one way you can always check it. And, the fact that I showed these two separately shows, okay, we get it. This inverse is not a function, but it's still an inverse. So inverse notation shows clearly that an inverse is literally doing the operation in reverse. So we find that when you take f of 2 and you get 3, then f inverse of 3 will come right back to 2. And you see how the ordered pair is literally reversed. If g of 7 is 100, then g inverse of 100 is 7. And so this idea of flipping the, interchanging, swapping the x and the y. Okay, so let's see, what am I doing here? So we've got y equals negative x plus 6. We swap the x and the y, and you get y equals negative x plus 6. So this one, what you get is, let's see, how can I... So the inverse is literally, it's the same thing. So on this one, the inverse of the function is itself. So you're going to see the book will talk about one-to-one functions, okay? And this function here is not one-to-one. And the reason is the original x squared blue that you see here, if I reverse it, if I inverse it, it's going to give you that red plus or minus the square root of x, which is not a function. So one-to-one means, actually, does the original function pass the horizontal line test? So take the original function, pass a horizontal line through. If it crosses in more than one point, then the function is not one-to-one. That is, you can still find its inverse, which I've done here, but the inverse will not be a function. So when you see the book talk about one-to-one, what they're saying is, by looking at a function, you can tell if its inverse will be a function. Because, when you tip this sideways, you can see that it will fail the vertical line. So the blue is a function, but it's not one-to-one. That is, its inverse will not be a function. Okay, here's number 31. Y equals the principal square root of x. All right, we swap the variables, and we see that. So this one is a function because it's just a principal square root of x, and when you flip it, when you find the inverse, you get this two. Let's see, how can I explain this? So let me just call it Desmos, and we'll take a look at this real quickly. So when you do, so there's the square root of x. And when you take its inverse, you get, you literally get x squared. And you can see that what was originally a one-sided now becomes a two-sided. So, that's kind of an unusual situation. All right, let's go back here. All right, now let's take a look at a problem like 65 here. So 65, this is a cubic, and the original function's up at the top here, x cubed plus 2x minus 1. They want you to find f inverse at a. So in other words, if the answer to this is A, what is X? Well, you can't find the inverse in the normal way because, for example, if you look over here on the right, okay, let me grab my pen. So if you look over here on the right, we've got the function written out. We swap the X and the Y. And what you can't solve for Y. You see how you come down to X plus Y equals, I guess you can factor it, Y times Y squared plus 2. But you can't really, there's no good way to get this down to Y equals. So on a problem like 65, we could still, here, let's just write, we know the answer is 2. So we write 2 equals that thing. Can we find 1? And on a problem like this, because it's fairly simple, you can figure out that, well, if X was 1, 1 cubed is 1. 2 times X is 1. 1 plus 1 is 2. 2 minus 1 is 1. So just by, with a cubic, you can't always solve for Y. And so you have no choice but to try it until you get it. Okay, let's look at this one. So we've got a quadratic again. Y equals X squared minus 8X plus 1. So we swap the variables, X and Y. All right. Now, I'm going to show you something here. I don't know if you guys, how many of you know the technique, completing the square. So what do we have here? X squared minus 8X plus 1. So what you can do, a technique called completing the square, is you can just kind of split, you know, like in football, send the plus 1 out to the right, flank to the right. Anyway, we can complete the square on the X by doing this. What's half of 8? 4. And what's 4 squared? 16. So I'm adding 16. Of course, I can't just add 16. To make it legal, I also must subtract it right away, which I know sounds like insanity, but this is now a perfect square trinomial. And so I can write it as X minus 4. And then I just combine these two out here. I can add 15 to both sides. And then I can take this, I can take the square roots of both sides. And then lastly, I can add 4 to both sides. So that's the technique called completing the square. So hopefully you're familiar with that. So that's what I did up here to complete the square. Yeah. Anyway, so like I got down here, I got these two answers, 4 plus or minus the square root of y plus 15. You can see that's one of those that's what? Not going to be a function, but it's an inverse. And when you plot it, you get these two, the purple and the black. And you notice with the original function in orange, that forms a nice symmetry with respect to the green line. Okay, so now trig inverses. This is right from the assignment page. you can see that what we've got here is an y equals the arc cosine of x. So what that means is, arc cosine is the opposite of that. So what we're saying is when you take the cosine, you get x. And the arc cosine is the angle that results that gives you y is the angle that gives you the result cosine x. So do you notice adjacent over hypotenuse is literally x? Okay. So using the Pythagorean theorem, can you tell me what this is over here? Well, you know what's going on here. You've got this, you've got one leg squared plus this missing leg squared equals the hypotenuse squared. X squared box squared equals 1 minus x squared. I'm sorry, that's supposed to be a squared here. And that means box is equal to the square root of 1 minus x squared. And now that you know that, you can do these problems. They're saying, all right, what's the cosine of y? So now that I've got all three sides of the triangle, the cosine of y is what? Well, cosine of y is x. Leg adjacent over hypotenuse. What's the sine of y? The square root of 1 minus x squared over 1, or the square root of, so this is x. Well, get my pen. This one is. The tangent is divided by, opposite over adjacent, So once you've got the triangle solved for, then you can easily continue. And so arc cosine is what? It's a way of saying go backwards. And the answer, y is the angle, and the arc cosine is a way of expressing this expression. So instead of saying cosine x equals cosine of y equals x, this says y equals the arc cosine of x. So it's a backwards way. Okay. So core exercises. And here we are. We're at 1.5. And there's the assignment for tomorrow. 1 to 7, the odd, 9 to 12, 45, 48, 87 to 94, etc. Okay, so those are the ones I want you to work on. So I see somebody was having trouble hearing.
It's all good now. It's on my end.
Oh, okay, good. So I wasn't keeping my eye on the chat there. So what do you think? Is everybody ready to go? Do you have any questions? I guess this was a quickie today. Does odd mean all odd numbers? So when it says 1 to 7 odd, that means 1, 3, 5, 7. 9 to 12 means do all of them. 9, 10, 11, 12. 87 to 94 means 87, 88, 80, do all the ones in that section. 107 to 111 odd means just 107, 19, 109, 111. Yeah, you're right. So anyway, That's the meaning of the assignment situation. Anybody else? Any other questions? All right, I guess that's it. I'll post the video. I'll see you tomorrow.